To many people, the word radiation means nuclear holocausts, devastation, and slow, painful death. But radiation is a part of everyday life, a part that can be a useful tool, performing diagnostics in medicine, or a means of communicating around the world. Radiation is a general term for a form of transportation of energy from one place to another without a medium. We've already seen one form of radiation in our energy unit, heat radiation. We talked about it as one of the ways heat energy moves from one place to another. Most vehicles have radiators on their engine to radiate away excess heat. Even your body radiates. Besides radiating heat energy, you are naturally radioactive. Radioactive ingredients are part of your body chemistry. In fact, by the time you reach old age, you will have received the equivalent of several dental X-rays, both from yourself and the natural radioactivity of your bed partner. It's by the process of radiation that the sun sends energy across space. Plants use it to make food. It drives the weather. And sometimes we use it to slowly cook ourselves to a crisp. This is how radiation is a two-edged sword. It's useful, but if not handled properly, it can be extremely dangerous. Overexposure to radiation can affect the very foundation of life, the DNA molecule, causing mutations and even death. It's even believed that ultraviolet radiation from the sun is responsible for the effects of growing old. It is therefore the responsibility of any technician working with radiation to know its hazardous effects so they can be avoided while trying to take advantage of the practical uses of radiation. Radiation comes in two forms. One is electromagnetic, which we mentioned briefly in our unit on waves and vibrations. The other form is nuclear radiation. Energetic particles that come from the nucleus of an atom. Nuclear radiation comes from radioactive materials like uranium. Both forms, electromagnetic and nuclear, are found everywhere in the universe, yet they come from within the tiniest structures, the atom. Electromagnetic radiation is produced by moving electrons, a cloud of rapidly spinning, negatively charged particles that form the outside shell of the atom. Sometimes electrons are very loosely bound to the atom and can be moved freely between atoms. This is the movement of electricity, the flow of electric charge in wires. Electrons are charged, so when they accelerate, they can cause a disturbance in an electric field, like a stone making waves in water. They also cause a disturbance in a magnetic field. These disturbances can be represented as sine waves. Since these waveforms are both electric and magnetic disturbances traveling together as a single form of radiation, that form is called an electromagnetic wave. Two waves at right angles to each other traveling together. This form of radiation, as you will see in one of our later units, is one of the most useful and versatile forms of energy to ever be discovered. Generating electromagnetic radiation is done by simply changing positions of electrons in the atom. Electrons occupy particular energy levels. They can be forced to jump to higher levels by injecting electrical energy into the atom, or simply by banging the atoms together with heat energy. But soon the electron returns from its higher energy level back to its lower energy level or ground state. This jumping from a low energy level to a high one and back again releases a pulse of electromagnetic radiation, which could be in the form of light. This unit of light energy is called a photon. The red glow of hot objects is electromagnetic radiation given off by the excited atoms. Nuclear radiation, as you can probably tell by its name, originates in the nucleus, the center of the atom. The nucleus is made up of particles, some positively charged, some with no charge. These particles are bound together by very powerful and useful forces. In some elements like uranium, a natural form of decay takes place. The nucleus actually disintegrates. Pieces of the nucleus fly off as radiation. The radiation is mostly in the form of these particles. There are three types of nuclear radiation. The first is alpha particles. They can be stopped by a piece of paper. The more energetic beta particles will pass through a single piece of paper, but are stopped by a book of paper. The third is the very energetic gamma rays, which are actually electromagnetic radiation. They will pass through a book. And even a piece of steel only partially reduces their intensity. The type, and more importantly, the intensity of nuclear radiation will determine the amount of protection needed, such as these lead-lined walls and remote manipulators. All radiation can be dangerous, but if handled properly, the energy stored within the atom can be converted into other useful forms of energy, such as electricity. Particle radiation can be used to break apart other atoms, release more energy, and sustain a nuclear chain reaction, the heart of a nuclear generator. It's the heat from this process that is used to produce electricity. Particle radiation can also be used as a tracer. By mixing small amounts of radioactive materials with other liquids that can be injected into the body, physicians can see what's happening inside a living brain, as seen by this PET scanner. In technical language, PET stands for positron emission tomography. In industry, gamma rays can play a similar diagnostic role in quality control of parts. There are many rightful concerns and also many misconceptions about radiation. This unit will take an objective view and present the facts about radiation itself.